Hello. Well, Dick is still off on his favourite activity of winding up other people's estates. And he's not due to come back until April. So that has slightly held me back on Woodstock things, because Dick has got the deck of the boat at the moment and the mast. So this is going to be a slightly different video about my experience with electronics in the past. Some 65 years ago, and about 30 miles from where I'm sitting now, I was quite interested in trains. These ones were clockwork, but I had an enormous amount of fun with them. As I got a bit older, into my early teens, I developed an interest in electronics. I don't actually have a picture of that when I first started electronics. I think this picture, I'm probably 17 or so in it, but that's at home with God knows what that electronics is, probably some digital thing pretending to be a computer. That's in the days before they had proper computers. Of course, the first thing you need if you're getting interested in electronics is to be able to buy components. And in those days, Maplins did not exist. Come to think of it, it doesn't exist today either, because sadly it went out of business last year. But what did exist was that in every town there was a little radio shop which sold radios to people and which repaired them and put up your aerials and things like that. And probably in a back room of these radio shops there was a man with an oscilloscope and an RF signal generator, and he would align your superheterodyne if it needed to be aligned. At least that's what they called IF in those days, intermediate frequency. So those shops needed components, and a firm came into existence called Radio Spares, the clue is in the name, to sell components to radio shops. And like everybody else in those days, there was a very strict delimitation between wholesalers and retailers. There was no way that Radio Spares would sell components to an ordinary member of the public. Oh no, they would only sell to bona fide incorporated electrical companies or radio shops. And certainly there was no way they would sell components to a 13-year-old boy. So I had to order my components indirectly from radio shops. And the radio shop in my local town was called Supersonic. So here's a picture of it. I think this picture is even older than I am. I couldn't get one that was exactly the same date. It didn't look quite like that when I was there. But I used to go down to Supersonic and place my order, and they kindly agreed to order the components on my behalf. And a few days later I would go and collect them. Whether they marked the price up or not, I wouldn't like to say. I've still got some of these components. This is a tray of resistors, half-watt resistors, 2.2K to 22K. And you see it says, you won't see, it says Radio Spares on it. These are half-watt, 10% carbon resistors. Of course, I don't use them nowadays, but I still seem to have got them. And here's a little card of 0.005 microfarad ceramic capacitors, of which I appear to have used one. When I went to school, I was able to order Radio Spares components through the physics department. And later, when I went to university, similarly I could order through the physics department. And later still, when I lived in Kent, it happened that one of my neighbours had an electrical company, and he used to let me order radio spares components through him. Eventually, Radio Spares changed its name to RS Components, and now they're a big online firm, and they will graciously deign to deal directly with me now that I'm a grumpy old man. So now at last I can actually order components directly from Radio Spares. But that was a bit of a problem in the early days. Of course, the other thing that you need if you're first getting into electronics is a multimeter. The concept of the multimeter was invented in 1923 by a British guy called Donald McCaddy, who worked for the GPO, the General Post Office. They looked after telephones in Britain before they invented British Telecom. And he made a multimeter called AVO, which stood for amps, volts, ohms. And that was the whole feature of it. It measured all three things. AVOmeters were really nicely designed. They had a really big meter, easily read, with a mirror behind it so that you could read it without parallax, and it had a dual movement, which was nicely stabilised. And they had a rather cleverly designed set of two symmetrical knobs for selecting the range in the days before things auto-ranged. And with one of these knobs you could set it to DC, and then all your DC options were available on the other knob. Or if you set the first knob to AC, all the AC options were available on the opposite knob. So it was really nice, and these knobs felt nice, and they made a nice clicking sound as you moved them around. So when I first got into electronics, I wanted to get an AVOmeter, but unfortunately I simply could not afford to. This here is a picture of an AVO Model 8 in 1953, and it costs in today's money £571, which was more than I could afford. So I did what lots of people did in those days. I built my own using a Heathkit. Heathkit was a firm that gave you the components and the design and instructions, and you provided the labour, thus getting something cheap and having a lot of fun at the same time. So I've still got this meter. It's here. It wasn't as good as an AVO because the meter was not that big, and the controls didn't have the two nice big clicky black buttons. But it worked fine. It still works today, although I hardly ever use it, naturally enough. And that's what it looks like inside. In those days, high stab resistors were enormously much bigger than they are today, which made it easy for a beginner in electronics to solder them up. And this space here is for a battery, which is needed to drive the ohms part of the measurement. And the kind of battery they had in those days was called a grid bias battery, because it was mainly designed to be used for applying a bias voltage to the grid of thermionic vacuum tubes, valves as we call them in Britain. But the nice thing about grid bias batteries is they had about 8 little sockets, and you could, by plugging into different places, you could get all kinds of different small voltages out of them. Not that this needed that, it just needed one fixed voltage, but that's what went in there. Heathkit Daystrom, Gloucester, England. Price 10 and 6. Assembling and using your Heathkit multimeter. These instructions are dated 7/62. I would have been 15 at the time. They tell you all about the resistor colour codes. They give you the specifications of the instrument, which I know doesn't actually say what its accuracy is, but it tells us that the resistors are 1% precision. And they give you big fold-out diagrams of how to assemble everything. And instructions about how to solder, step-by-step instructions which you solemnly perform one by one and tick off as you go. Of course, nowadays I mainly use my Fluke H7V, although I have got an even bigger table-mounted multimeter which is more accurate than this. Funnily enough, this meter is not accurate enough to test the specification of an AVOmeter. We'll come on to that. Now, one of the advantages of being a grumpy old man is that you can afford to buy things that you couldn't afford to buy as a child. AVOmeters have not been manufactured for some years now because we all use modern digital ones. But they're still available on eBay, and often they're sold by people who've inherited them from grandpa and don't really know what they are, so they sell them for spares and repairs. So I bought one off eBay for about 30 quid. Well, actually I bought three. This is the case of one of them, which is a NATO variant. Quite big things, aren't they? And this video is really about what I did with those eBay AVOmeters. I bought this AVOmeter Model 8 Mark V on the internet, untested. But I was lucky, it turned out to be in a very neat state. And when I opened the battery compartment, the original AVO seal was still there. And on taking it out, it's really in a very clean and neat state. There were 3 faults on it, but I've managed to correct them all. First fault was that the ohms times 1 range wasn't reading at all. That was due to a dry joint here. Second fault was that the meter needle was slightly bent, but I managed to straighten it. And the third fault was that on low current DC readings, it was ranges, it was reading a bit low. And I traced that to this resistor here being slightly high, so I've shunted it by a 1.4 meg resistor, and that's brought the whole instrument back into calibration. I've tested it, and it's within plus or minus 1% on all ranges now. Well, so much for that. I bought another one off eBay. Bought this off eBay, and again it's untested. And this time it's a Model 8 Mark V, but a NATO version. This also still has a seal in place, which suggests to me that it's never been opened. But I'm just going to test it now, because it just doesn't look right. It's very underdamped. So we'll start off by putting a voltage on the DC volts range. again, the meter is very underdamped, and I've got 14 volts on the 30 volt range, and it's showing 20 volts already, so the thing is clearly overreading substantially. It's showing 30 volts when it's only 22 volts. If we try it on the 50 microamp scale, which is the one that's most directly connected to the meter, I'm going to use this fluke just to measure the current. I'll just set it up without the meter in circuit first. So that's 46 microamps. And if I put the meter in circuit on the 300 microamp range, it goes way over, and the cutout operates. So what I think is most likely, the shunt has burnt out and is not across the meter at all. So what we'll do now is take it apart and have a look. Right, well, the seal was intact there, but I've just pushed it aside. I'll take these 4 screws out. Right. What will we see? Well, it looks quite nice, and clearly, it's interesting. This track here has incinerated. Let's see if we can get a close up of that. Here is the shunt, and you can see that the copper here is completely vaporized, or turned to carbon would be more accurate. So that explains why that's not working. However, everything else looks rather nice and clean. Maybe we should take the meter out. First thing we need to do to get the meter out is to disconnect this black wire here, which is connected to the meter, and also these red and black wires here, which come directly from the meter. So we'll take these two those clips off. We just need to unsolder, not this little one, but the big one. This is not how to do it, however I've done it. See if we can get these off in a more elegant way. we just need to remember that red is 2. It says 1 and 2. Red is 2, black is 1. So I'll just get those out. That's it. Right. So that's the meter unwired. Now we've got to take this board off. This little plastic screw here. Don't know what this does really. I suppose it just provides a little stability for the PC board. Another one of these things at the back here. Which has a shake-proof washer on it. And another one here, and we have to remember that it's got a black wire on it. That also should have a shake-proof washer on it. Yes. Right. So this board should now come up. It does. And we can get rid of that and that. So everything looks nice and clean and okay on the underside of this board, which is good news. What we have to do is unsolder this other thick wire. This is the 15 amp wire that goes between the shunt and the meter, which is difficult to do because you've got to hold the board and the soldering iron and the wire with your 3 hands, which isn't always the easiest thing to do, but I think I do it like this. No, I don't. More solder required. I think it'll just come off if I just do this. Yes. Right. So now the meter is completely unconnected to anything. The problem with this wiring is that you can't get rid of this board. It's just stuck here. You've just got to hold it out of the way. Now to get the meter out, we need to undo these 4 posts, or at least these 2. Let's see. Get that one off. Yes. All right, you want to be awkward? Right, so that's freed the front of the meter. I don't think we need to get those posts out. What we've got to do is we've got to get this screw out here and another one, which is, I don't know if you can see that, down there. So I'll do that one first. Because this thing is in the middle of the instrument, I'm going to take it out carefully with that. There should be a washer on top of this. There is, but I can't. I've just lost it, but we'll get it back in a minute. Let's get it back now. Well, Still haven't got it back, but we will do it eventually. And finally this one, which is awkward because it's at an angle, because you can't get this out of the way, this PC, flexible PC thing out of the way. That one does have a crinkle washer on it. So I'm missing one crinkle washer at the moment. Right. There is now no good reason why this meter should not come out, says he famously. Famous last words. That's it. I just put that upside down for a moment. When you take this off, you will find that there should be a crinkle washer underneath the meter, here and there, and that's true. We've got 1 and 2, and also there is a washer on here, not a crinkle one, a plain one, and there should be another one on there, which is not there at the moment. I don't see it. Well, let's take this out to see if it's underneath. It's not underneath. So we've lost a crinkle washer from there, and also a plain washer, unless it is stuck to the bottom of this. If it were stuck to the bottom of it, we would see it here, but it isn't. So that's that for the meantime. Let's see if I can find this crinkle washer that should have been there. Well, maybe there never was one. Right, we've got to put that aside. Have a look at the meter. Here is the meter. Let's see if we can get that close up. Oh, here's the crinkle washer. Found it in the end. Right. See how sensitive it is to air. Very light blowing on it. Let's have a look on the back. You need to be careful not to touch this needle. I just wanted to see the cut-out mechanism, which it looks okay. So, just to test that, if I move the needle down, it goes, and if I move it up here, it goes too. That's all right. Well, now I'm going to look at the hairsprings. And you won't be able to see this, so maybe you will. Seems to be all in the same plane there, which is good. So what I'm going to do is leave this meter alone, because it seems to be all right. And we'll look at the shunt instead. Well, now I'm going to see if I can unsolder this shunt, the whole of this board. So I think I need to get 1, 2, 3, 4 of these things undone, which is not easy with all this. There's no way of holding this, which is a frightful nuisance. At least I haven't got a way of holding it. I'm going to try and do it like this. This is a substantial metal pin, so and 4 of them. Plus, this one goes directly to the tunnel over here, which is well, not the common tunnel, the other one. That off. Actually, it goes to the switch. Now, the thing is, can I now get this thing off? Let me put my finger between them and see if I can just free it a bit. Nope. Try and get a bit more off here. This thing should come off now. That's better. Hurrah! Ouch! That's hot, as you might expect. Right, well, we've completely ruined that meter now, so we can throw that in the dustbin. And we're left with this. And that is the shunt PCB. I don't know if you can see that. Well, there's the shunt PCB. Maybe it is. Maybe this is the 0.04 ohms shunt. I think that's what it must be. Which is used for the 15 amp range. Looks all right on the back. Well, we're not going to be able to do anything. We could just solder in a replacement for that. What this is. Copper is still there. I don't know if you can see that. The copper is still there. It's just, but it's burnt through there. Well, what I decided to do about this shunt is that I've got here a bit of another Model 8 Mark V, which is really beyond repair for various reasons. You can see these yellow wires that somebody else has fixed to it to cater for the fact that the flexible PC board is no longer working properly. So what I've done is I've removed the shunt from this board and fitted it to the one we were working on before, and here it is in place. I put it all back together and it's working. Here it is with the replacement shunt soldered in, and I've tested it, and the meter is now working okay, except it's reading slightly high on some ranges. What I've done is I've put the meter on off and on the position between just to the left of DC, which disconnects the meter from the shunt. And then I'm going to measure the resistance of the whole of the shunt, not just the bit that I've replaced, but the rest of it, which I can do on here. I don't know if you can see that, but it's 8018.4 ohms. It's supposed to be 8000.3, so it's 18.1 ohms too high. You have to be careful when measuring the shunt resistance, because you have to take account of the error on the instrument that you're using. I'm using a Fluke 8846A, which has an error of plus or minus 0.9 ohms on this range. So the figure I'm measuring is certainly 17 ohms too high. In fact, I've measured all along this shunt, and I've decided that the top two resistors are slightly high, and I'm going to solder in parallel with those a resistance that I've calculated, which should bring the thing back into spec. I need to put a 3M3 resistor across here and a 255k resistor across the next one. Right, I've just done that. I think you can see one of the resistors there. There's another one a bit further down. Yeah, there they are. So now if we measure it, the shunt as a whole, it's 8001.4, which, if we allow for the plus or minus 0.9 ohms accuracy on the Fluke meter, is within spec. It's still slightly high, but that should be better. Well, these are the measurements I did on that NATO AVO Model 8 after I had replaced the 0.04 ohm shunt and corrected those other three shunt resistors. And I'm using the Fluke 8846A as the master measurer. And as you can see, the whole thing is completely in spec, except for one range of the ohms times 1. Well, actually, I didn't test the rest of the ohms. I'm really not interested in the ohms, because nobody in the modern world would measure ohms in the using the technique that these analog meters had to use when you've got a digital meter that will do it properly. But apart from the ohms ranges, everything is okay. And I couldn't test it right up to 1000 volts because I didn't have the ability to generate more than about 600 volts, but I tested it as best I could. Anyway, basically, it's nicely in spec. Well, there you are. That's what happens when grown men go back to their childhood. I've had this video in the pipeline for a long time, just wanted to get it out of the way before Dick comes back and we get back onto Woodstock work. Dave Jones of EEVblog made a YouTube video last year when he explained all the reasons why you never need to use an analog meter, why digital meters are always better than analog meters. And he's basically right, but sometimes I just like to see a waggling meter needle, and that's why I've got these AVOs back into working condition, and I expect to show them in use shortly in connection with my solar panel research. I'm sorry this video has been so long. You're not compelled to watch it. You can always go and do something more interesting. Anyway, thank you very much for watching it if you're still here. and hope to see you next time.